All right, so it says the point given is on the terminal side of an angle in standard position. Find the exact value of the six trig functions of theta. So we are given x and y. We need to find r. So x squared plus y squared equals r squared. This is a Pythagorean triple, 7, 24, 25. So r does come out, excuse me, r comes out to 25. You can save yourself some large number computations there. For all the problems where you're given an ordered pair, it is a good idea to plot the ordered pair. 7, 24 is in quadrant 1. Okay, so the reason that's important is because it'll help me figure out maybe what's positive, what's negative, if I need to. So we have sine of theta is equal to y over r, so 24 over 25. Cosine of theta is equal to x over r, so 7 over 25. And tangent of theta is equal to y over x, 24 over 7. And then we just write the reciprocals. So cosecant theta is 25 over 24. Secant theta is 25 over 7. And cotangent theta is 7 over 24. That's it for our first one. For the second one, again, you can plot this point, negative 24, 10. You'd be in quadrant 2. Now, remember last section when we had a triangle that had two side lengths that had a common factor, you could reduce them. Like right now, tangent of theta would be 10 over negative 24. You can reduce that. So because we're just using trig, we can come up with a similar triangle if we have a similar point by just dividing by 2. So I want to look at this as negative 12, 5. And that's helpful also because then I don't have a bunch of math to do. I'm seeing that this is a triple as well. X squared plus y squared equals r squared should give me a 5, 12, 13 triangle. And r is always positive, so you don't have to worry about what's positive and what's negative. All right, so sine of theta is y 5 over r 13. Cosine of theta is negative 12 over 13, x over r. And tangent of theta is y over x, so 5 over negative 12 or negative 5/12, whatever. Cosecant theta is 13/5. Secant theta is negative 13/12. And cotangent theta is negative 12/5. Okay, last one, and we have x and y. Last one in this section, I mean. This one I do need to do. It's not a triple, so I need to do the math on. So x squared plus y squared equals r squared. We're allowed to use that, remember, because all of these are points on a circle. That's a circle equation, or you can think of it as Pythagorean theorem. It's all the same idea. When I square a negative, I get a positive. When I square a radical, I'm left with the number underneath. So square root of 7 squared is 7. Negative 3 squared is 9. 9 plus 7 is 16. And r is always positive, so r is equal to 4. So sine of theta is y over r, negative 3/4. Cosine of theta is x over r, negative radical 7 over 4. Tangent of theta is y over x, negative 3 over negative radical 7. So the negatives become positive, and I rationalize to make it 3 radical 7 over 7. For the reciprocal functions, cosecant theta is negative 4/3. Secant theta is negative 4 over radical 7, which is negative 4 radical 7 over 7. And cotangent theta, flip this version here. It's still positive, and it comes out radical 7 over 3. Determine the quadrant in which theta lies. This is just quick practice since we're not going to be given ordered pairs in the next section. So when sine is negative and cosine is negative, which quadrant are we in? Remember, this is the all students take calculus. If sine and cosine are both negative, you must be in quadrant 3 where tangent's positive. Secant is greater than 0. That's the same as saying cosine will be greater than 0 because they're reciprocals of each other. So they share the same positive or negative sign. So cosine is positive and cotangent's negative, so tangent's negative. So which quadrant has cosine positive, tangent negative? You've got to be in quadrant 4 because all students take calculus. That's where cosine's positive, everything else is negative. Sine is positive, tangent's negative. Sine's positive in quadrants 1 and 2, and tangent's only negative in quadrant 2 out of those two options. So we're in quadrant 2. All right, now that leads us into this next section. So find the exact values of the remaining 5 trig functions. All right, so this tells me theta's in quadrant 2. So that's great. You can sketch this if you want to. If I'm going to sketch it, I just put a terminal side in the quadrant I should be in. And I'm looking to plot a point. So sine is y over r. So r is 5, y is 3, and I can do Pythagorean theorem, or I know that this is a 3, 4, 5 triple, so x has to be 4. But I need to be careful here. I'm in quadrant 2, so x is negative 4, right? Because I'd go left 4 and up 3. All right, so, and that's why the quadrant matters. So you know what to make negative and what to make positive. So cosine theta is negative 4 over 5. Tangent theta is 3 over negative 4. Cosecant theta is the reciprocal of sine, so 5/3. Secant theta is negative 5/4. And cotangent theta is negative 4/3. For this next one, secant theta is negative 3. I don't think well in terms of cosecant, secant, and cotangent, so I like to flip this around. Cosine then would have to be the reciprocal of that, which is negative 1/3. And this says that theta is between 0 and pi. So we saw that in our notes. Telling us that theta is between 0 and pi just tells you you're restricted to the top half of the circle, and cosine is negative. So out of quadrants 1 and 2, which one is cosine negative in? Quadrant 2. Okay, so so theta is this. What about x, y, and r? So cosine is x over r. Remember, r is always positive, so that helps you figure out cosine's negative, or x is negative 1. And then we're going to need to do Pythagorean theorem. X squared plus y squared equals r squared. Y squared equals 8. Y equals, is it plus or minus 2 radical 2? Well, we're up here in quadrant 2 where y values are positive, right? You're above the x-axis. The rest is just following your formula. So sine is equal to 2 radical 2 over 3. Cosine theta is equal to negative 1/3. I already had that from the reciprocal. Tangent theta is equal to y over x. So radical 2 radical 2 over negative 1. So negative 2 radical 2. Cosecant theta is 3 over 2 radical 2. So I need to rationalize that. That's 3 radical 2 over 2 times 2, which is 4. We already were given secant. Cotangent theta is 1 over negative 2 radical 2. So rationalize. That's radical 2 over negative 2 times 2 again is 4. All right, what about this one? Tangent theta is undefined, and theta is between pi and 2 pi. So here's pi, and here's 2 pi. So opposite of the other one, now they're saying you're restricted to the bottom half of the circle. Where is the y over the x equal to something over 0? It can be plus or minus 1, it doesn't matter. Where is the x coordinate 0 is basically what that's asking. So remember, x being 0 only happens at the top or the bottom of the circle. So you've got to be down here at 3 pi over 2. What I get from that is that I can use the unit circle here because the radius isn't mentioned at all. So 0, negative 1 is my x and my y. And I can find all the trig functions based on that. So sine of theta is equal to negative 1. Cosine of theta is equal to 0. We're already given tangent. Cosecant theta is the reciprocal of -1, still -1. Secant theta is 1 over x, so 1 over 0, which is undefined. Cotangent theta is x over y, 0 over -1 is equal to 0. Or another way to think of that is the reciprocal of undefined is 0. Okay, for this one, cosine's given as a decimal. We don't like that. I'd rather have a fraction, but remember, you're just making this, you can make this -8/10 and reduce that to -4/5. So not that big of a deal. And that shows me that this is x over r. And I know which quadrant I'm in because cosine is negative, and this says tangent is positive. So I should be in quadrant 3. The sketch is not entirely necessary, but I like doing it because otherwise I would forget probably to put in my plus and minus signs, or it helps you figure out whether the y or the x that you're solving for is positive or negative. All right, so x is -4. We don't know y yet. Figure that out. R is always positive, so it's 5. And we do know y. This is another 3, 4, 5. So y has to be -3. Because again, all of the xy's are negative in quadrant 3. All right, so sine theta, I'm going to keep my answers in fractions rather than going back to decimals. So sine theta is -3 over 5. We already had cosine. Tangent theta is -3 over -4, so make that positive 3/4. Cosecant theta is -5/3. Cotangent theta is 4/3. And that's it. All right, next problem. So this is what a speed quiz looks like. I'm going to show you how much of the unit circle I draw because you're not going to be given a ready-made unit circle to use on your speed quizzes. So again, it's okay if you're not fast at this right now. This is only the second time you've attempted this. So don't panic. It will get better. You will get faster. You could draw the entire unit circle if you want to, but again, it's not necessary. So here's what I suggest. Draw quadrant 1 and where the non-quadrant ordered pairs are. So what I mean by that is give yourself whatever size axes you want. I don't even really draw the circle in. I just mark off some things. So 1, 0, 0, 1. Here are the non-quadrants. -1, 0, 0, -1. You can mark in those angles if you need to. Put in the 3 quadrant 1 angles. So that's 30 and pi over 6, 45. Whether you do degrees and radians is up to you. 60 and pi over 3. And then the ordered pairs. So this is something to memorize. If you know the first one, hopefully you get the rest straight. So the first one starts with radical 3 over 2 and then has 1/2. So I have memorized, the one that I have most solid in my head is sine of pi over 6 is 1/2. So I put that in the y and then I do the x. Pi over 4 should be the easy one. They're both radical 2 over 2. And if you have pi over 6 right, then pi over 3 is just flip these coordinates. 1/2 and then radical 3 over 2. Now, this is where I start, and then I have enough information to go about finding the rest of these values. So secant is 1 over x. Maybe you make a note for yourself there. Go to 45 degrees. X is radical 2 over 2. The reciprocal of that is radical 2. That's another thing I do have memorized, because remember, this was 1 over radical 2 before it got rationalized, so flipping that is nice and easy. Tangent of 4 pi over 3. Well, here's how I do this. You can do this a different way if you want. You could mark off where 4 pi over 3 is, and then you could write the entire ordered pair if you want to. So remember, it's just here's pi over 3. Just make it negative. And then you could say, all right, tangent is y over x. Negative radical 3 over -1 is radical 3. Sine of pi over 3, look at the y value for pi over 3. It's radical 3 over 2. Cosine is x. Cosine of 330. Now 330 is down here. And its ordered pair is the same as the 30-degree angle, but it's down here. All right, so the cosine at that angle is positive radical 3 over 2. If you don't write the angle down, what I do is I figure out the cosine of 30. So sometimes I make a note like, okay, just do cosine of 30, and then you're in quadrant 4, so cosine's positive, you know? So sometimes I do like an all students take calculus thing. Cosecant is 1 over y. Go down to 270, flip the y value, you still get negative 1. Cotangent's x over y. So let's try this. So for cotangent, 4 pi over 3. So just go to the pi over 3 angle. Take a look at cotangent. It's 1 over radical 3. And then the second thing is, should this be positive or negative? This is in quadrant 3 where cotangent is positive. So I don't have to put a negative sign in. I just rationalize for my final answer. Cosine of 45 is the x value, radical 2 over 2. Cotangent of 120. 120 is up here. But really, I just think of this as a 60-degree angle. So what was cotangent of 60 degrees? It was 1 over radical 3. Should cotangent be positive or negative in quadrant 2? It should be negative. So my answer is negative radical 3 over 3. So that's how I go about doing these problems. All right, so sine of 7 pi over 4. Anything over 4, sine of pi over 4. Again, what's sine of pi over 4? Radical 2 over 2. Where is 7 pi over 4? Quadrant 4. So this should be negative because sine's negative down there. The x value at pi is negative 1. Flipping the y value at 30 degrees. At 30 degrees, the y value is 1/2. Flip that, you get 2. Flip the x value at 60 degrees, or pi over 3, I should say. So pi over 3, oh, my pen just stopped working. So at pi over 3, if I flip at 60 degrees, the x value, I get 2 as well. The x value at 0 is 1. 210 is in quadrant 3, and it's the same as the 30-degree angle in quadrant 3, right? Because it goes with the pi over 6. So I just say, what's tangent of 30 degrees? It's 1 over radical 3. Should tangent be positive or negative in quadrant 3? It should be positive. So now I just rationalize. Cosecant of 5 pi over 6. Think about sine of pi over 6. Sine of pi over 6 is 1/2. So flip that, 2. Where is 5 pi over 6? Quadrant 2. Sine positive or negative in quadrant 2? Positive. All right, I'm going to stop there because I'm going to get cut off by the bell, but I'll finish this in the next video.